Today we're talking about lines and segments that intersect circles. So we're going to identify lines and segments that intersect circles, and we're going to use property of tangents. So let's just start with some basic vocabulary. A circle is the set of all points in a plane that are equally distant from a given point called the center. A circle with center C is called circle C and can be written with a circle with a little dot in front inside and a C. Okay, so we have a center, and everywhere where I make a line between the center and the edge of the circle is equally distant. That is the radius, the length from the center to any point on the outside edge of the circle. Now, a chord is a segment where the endpoints are exactly on the circle. A diameter is a chord that goes straight through the center of the circle. And it is exactly twice as long as a radius, okay? So a radius is here. If I have two of those together, it's going to go through the center of the circle, and it will be twice the length of the radius. A secant line it's very similar to a chord, except it's going to go in both directions forever. So a secant line intersects a circle at 2 points, where a tangent line, this is very important, intersects the circle at only 1 point. This is called the point of tangency. So this would be this point B would be the point of tangency. A tangent ray, AB, and the tangent segment are also called tangents. So I could go from A to B and keep going forever that way, and that would be a ray. It is also a tangent segment, and they're tangents as well. If it intersects in one spot, it's a tangent. Okay, so let's talk about radii, kind of like when we have a cactus. One cactus is cactus, and if you have more than one cactus, it's called cacti. Now we're going to name 2 radii. That means more than one radius. Okay, so we have a radius. We could say A to F is a radius. So AF. We could say A to D is a radius. We could also say AB is also a radius. So those are 3 radii. You could say, it just says name 2, but that's 3. Name a chord. Now a chord is 2 points, or a line segment where the ends are on the circle. So EC is a chord. A diameter is a line that hits both sides, both ends are on the circle, and it goes through the center. So I am thinking DF would be a diameter. You could also say FD, either one is fine. Name a secant. A secant goes through the circle in 2 points. So ED or DE would be a secant line. I'm going to put 2 end lines because it goes on forever. 2 arrows on the ends. Name a tangent. Now a tangent is a line that intersects the circle in one spot. This line B is the tangent line. Okay, so this is B is going to have, line B is going to be a tangent line. The point of tangency would be point B, and I'm just going to put a little point there. We're going to name the circle. It's always named by our center. This is circle A. Put a little dot for the center, circle A. Okay, now tangent line to circle theorem. In a plane, a line is tangent to a circle if and only only if the line is perpendicular to a radius of the circle at the point of tangency. So if you have a point and it makes a tangent, or it only intersects the circle in one point, it will always make a 90-degree angle if you compare that line to the radius. Okay, also, if you have a 90-degree angle to the radius, this is going to be on a tangent line. So both ways it works. That's what the if and only if means. It will work both ways. A line L is tangent to circle C if it's perpendicular to the CP, the radius, and also if it's perpendicular to the radius, it's also a tangent line. Okay, now we have a four-sided shape on number 8. Every four-sided shape makes two triangles. Every triangle has 180 degrees, and if you multiply that, that's 360 degrees. Every four-sided shape, all of the angles inside the shape add to equal 360 degrees. Now, the lines that appear to be tangent are tangent. So these are tangent lines right here because it looks like it only goes through the circle in one spot. So those are tangent lines, which means if they're a tangent line, it makes two 90-degree angles at the point of tangency. So if I were to add all four of those angles, this is 90, 90, x plus 90 plus 90 plus 70 equals 360. I could find what x is by subtracting 90, 90, and 70 from 360. So if I take 360 degrees, I minus 90 and 90, that's 180. There would be 180 degrees left between x and 70. If I minus 70 from 180, I have 110 degrees left for angle x. Okay, number 9. If this is a tangent line, right here, it's going to make a 90-degree angle, which makes a right triangle right here. Now, every right triangle has a special property of Pythagorean theorem. A squared plus b squared has to equal c squared. If this is a right triangle, then this will be true. So let's check, and I'm just going to put a little question mark above the equal sign because I'm trying to figure out, is this true? So I'm going to take my two legs, 35 and 12, 35 squared plus 12 squared. Does that equal, the hypotenuse has to go in for C, 37 squared. So I'm going to take out my trusty calculator, 35 squared plus 12 squared, or 144, equals 1369. Does that equal 37 squared? Why, yes, it does. So since these are equal, we're trying to determine, is this a tangent line? Yes, yes it is, because the Pythagorean theorem holds steady here. Now, we'll look at number 10. We're doing the same thing. I want to see, is a squared plus b squared equals c squared. Is this a tangent line? Question mark. I probably should have put a question mark here. I don't know. But we can figure this out, because if a squared plus b squared equals c squared, it is a tangent line. If it doesn't work out, it's not. Okay, so let's look at this. We have 12 squared is one leg. Now, we have to be careful here because the 17.5, it looks like this is just the radius. The radius is 17.5. So if this radius is 17.5, the other half of the radius is also 17.5, and 17.5 times 2 is 35, or 17.5 plus 17.5. So I'm going to say for the other leg, I'm going to have 35 squared. Does that equal 38 squared? So we plug this into our calculator. 144 for 12 squared plus 35 squared. That equals 1369. We're getting lucky with this 1369 thing. Does that equal 38 squared? Well, I'm pretty sure it doesn't because 37 squared is 1369, but 38 squared is 14. This is not equal to 1444. So, no, this is not a tangent line. No. Okay, because the Pythagorean theorem did not work. Okay, but these ones, 11 and 12, they tell us that it's a tangent line. So we are trying to figure out what r is. So I know, since this is a tangent line, this is going to make a 90-degree angle. I'm going to use my a squared plus b squared equals c squared. The hypotenuse, the longest side across from the right angle, has to go in for c. 13 squared. A squared is r squared plus 11 squared, and you can put those in any order for a and b. I'm going to just minus off my 11 squared. Now make sure that you do not write that this is 2 squared. You cannot subtract 13 minus 11 first because order of operations says we have to do exponents before we do addition and subtraction. So we're just going to type it exactly into our calculator just as is, and we get 48. Now if I take the square root of both sides, normally when I take the square root of both sides, I need to remember a plus or minus. But since this is a radius, there's no way you can have a negative measurement for a radius. We will not be putting a plus or minus sign. We will just be putting this exactly into our calculator, and we will get 4 square root of 3. If you want the exact answer for your radius, it would be 4 square root of 3. However, they tell us to round to the nearest hundredth, so I'm going to change this so it's an approximation, and it's 6.93 units long for the radius-ish. Okay, now number 12. This one a little tricky because we have an r here, and we have an r here, and we have a 6 here. So we know this is a tangent line. So the rules of the Pythagorean theorem have to hold, where a squared plus b squared has to equal c squared. Let's start with the longest side across from the right angle, which is this AC. Now we have part of it is 6 and part of it is r. We're going to add those together to be 6 plus r, and we're going to square that whole quantity. Now we have our other two legs, 9 and r, and they are not nearly as problematic. 9 squared plus r squared. Now we have this 6 plus r squared. Anytime you're squaring something, you're multiplying it by itself. So we have 6 plus r times 6 plus r. And we are going to FOIL that. We take our first, 6 times 6 is 36. 6 times r is a plus 6r. And that's first and outside. Now we do our inside and last term. Inside, r times 6 is 6r. R times r6, we don't usually write. We write the number first and then the letter. And then r times r is r squared. Now I'm just going to rewrite this so it's in a little nicer order. I'm going to put r squared because that's the highest powered term. 6r plus 6r is 12r's. And then plus 36 is our constant term, so I'm going to put that last. Equals 9 squared plus r squared. Now, something really nice that happens here is if I minus r squared from both sides, they cancel out, and so this is not a quadratic. Pretty nice. I know 9 squared is 81. This equals 12r plus 36. I only have a r term. I don't have an r squared, so I don't need to set it equal to 0. I'm going to solve for r by minusing 36 from both sides of the equal sign. I get 45 equals 12r. I'm trying to get r alone, so I'm going to divide both sides by 12. This does reduce to 15 over 4, so r would equal 15 over 4 there. External tangent congruence theorem. If two tangent segments share a common endpoint outside the circle, then those segments have to be congruent. Now, I like to kind of look, I don't know, every time I see this picture, it just looks like a little happy face. Like if you were to like move that up, I feel like it's like a little party hat. This guy is wearing his party hat. And if you take both sides of those are going to be equal on the party hat, right? So if PA and PB are tangent segments, then PA, this length, has to be equal to PB. So we've got our little guy going to his party. And point B and D are points of tangency. So these only intersect at one point. If those are tangent lines, these two are going to be equal. So 3x plus 10 has to equal 7x minus 6. We minus 3x from both sides of the equal sign. We have 4x. I'm going to also at the same time add 6 to both sides of the equal sign. And I have 4x equals 16. So this is saying 4 multiplied by some number equals 16. Oh, that's 4 because 4 times 4 is 16. But you could also just divide both sides by 4 and x equals 4. Okay. Now we have a whole bunch of tangent lines where it only intersects the circle in one spot. The circle is inscribed in ABC. The perimeter of ABC is 40 inches. So if I add up all of these numbers, they would equal 40. So we need to make sure we keep that in mind. What is the length of BX and BA? So I know that if this length is 8, this length is 8. So I'm just going to write in 8 inches right here. If this length is 5, then YC is also 5 inches. Now I am trying to find BX, which let's just start with that and put an X there. But if BX is X, then BY is also X. So if I add up all of the pieces on the outside of this triangle, the perimeter is going to equal 40. So I'm just going to add them up. If I have X plus X, I have 2x, plus 5 is 10, and then plus 8 is 16, and 10 plus 16 is 26. So 2x plus 26 has to equal 40. I am going to minus my 26 from both sides of the equal sign. I get 2x equals 14, and so x equals 7. Now that is what x is, it's 7, so bx is 7, so bx is 7. Now we also need to find what BA is. BA is the length from B to A. If BX is 7 and XA is 8, we just add those together. That's going to equal 15. And both of these are inches long. Okay, each polygon circumscribes a circle. So the circle is just embedded as big as it can be on the inside of this polygon. So we want to find the perimeter of the polygon. So we have these points of tangency. If this is 36 centimeters, then this piece right here is also 36 centimeters. If we have 16 centimeters here, we have 16 centimeters here. If we have 14 centimeters here, we have 14 centimeters here. And last one, 19 centimeters, and we have another 19 centimeters. Okay, now we're just finding the perimeter. Easy. All we have to do is add 19 plus 19 plus 36 plus 36 plus 16 plus 16 plus 14 plus 14. Plug that into our calculator. And I got 170 centimeters. Number 16, same thing. We're just finding all of the little pieces. Now I cannot start with this 17 because this 17 is not only this piece, but it's this piece as well. And so I need to start with this 19 because I have this piece here is 19, so this piece here is 19. I'm just going to write a 19 here. This whole length is 26. If this piece from here to here is 19, I have 7 units left for this piece. I have 7 units left for this piece. And then this whole length is 14. If this is 7, we have this little piece is also 7. We have 7 here. And this whole length here is 17. This piece is 7, so there's 10 feet left here and 10 feet left here. So now we add them up. Now I already know this is 17, this is 14, this is 26. So add those 3 and then add the 29 for 10 plus 19. And that gives us 86 feet.